going to take a look here at 3 examples. Conversion to standard form for hyperbolas, where graph data is going to be listed after it's done. And the first example is underway with the rearrangement of its terms. And remember that this is in preparation for the completion of the squares for both variables. And you can see that x requires factoring before the process gets started. Y does not. And in this next set of steps, you can see balancing both sides after the squares are complete. And that gives 70 as the constant on the right-hand side. And that becomes the divisor, dividing all terms equally, of course. And when that's done, we can see that we've got pretty close to standard form after we reduce, but we can rewrite it so that now it's in the correct order to be truly in standard form. So that's our answer, but now we're going to explore further to get some of the graph data from it, and specifically here, getting some lengths so that we can list some important points, such as the center, which comes from the numerator, and the vertices and the foci, which we already found those lengths involved from the denominator of those terms. And here is a graph of what this hyperbola might look like with the asymptotes labeled as well as dashed lines. Our second example, pretty much the same sequence of steps, and you're going to see in the first step the rearrangement of terms again, and this time lacking a y term. Well, that's going to make our job a little bit easier, I guess. But we're ready now for completing the squares. And really, the y square is complete, so we're not really going to do anything to that. It's the x where the factoring happens. We figure out that missing constant. We put it in there and now balance on the right-hand side with the addition of what turns out to be 375, so that our divisor now will be 600. And dividing the terms equally, again, that 4y squared just sort of sat there. It gets divided by 600 as well. And we see that the standard form for this example turns out to be pretty nice, with really a nice preparation then for getting a good graph of this example as well, where you can see my rewrites here so that those key lengths can be described and seen clearly, and that allows me to list now some, again, important points for what a graph of this hyperbola might look like. And if we're lucky, we're going to get a look at this one in the next image. And hopefully the simplifying of those radicals didn't bother you too much. There's a little more of it in here, if I remember correctly, to get those slopes right. But here is that hyperbola. And now we're ready to move on to our final example. And here it is. A little bit more rearrangement this time to get the terms in the right order and on the right sides and so forth. But now we're ready to proceed, and if we proceed as we've done already with completing these squares, it's looking pretty good, factoring on the x as we've seen already, this time just of a negative. I'm going to rewrite it, as you see, as a -1 about midway down here, but as I balance, pay attention there that this time the divisor is a negative number. And when that ends up becoming our divisor, when we divide all terms equally, it is going to end up changing the sign on that first term and on the second, so that instead of negative followed by positive or minus followed by plus, we now have it really in standard form right away after that reduction is complete. It's more of a sign change than anything else. But finally, we have a chance to prepare for a graph by identifying those distances one last time. And looks like the focal length turned out nicely this time, so that some important points can be observed and listed here. And that's going to lead us to hopefully a reasonable looking rendering of this one with the asymptotes listed there again for us. Slopes being 1 and -1 for this last example. Thanks so much.